Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Okay, let's do some questions about ionic bonding. So ionic bonding, just as a reminder, is the bonding you get between ions because there's some electrostatic attraction between positive and negative ions. And this question here is, can I find the ionic formula for strontium fluoride? Okay, so first things first is to know what those two ions are that are being bonded together. So the first one is strontium, that's Sr in my periodic table, and it's group 2. It's a metal, okay? And fluorine, F, is group 7 and is a non-metal. Remember, it's called fluorine as an atom, fluoride as the ion that fluorine atoms form. So we have strontium is Sr plus 2. And that plus 2 for my ion, remember from our previous work, comes from the idea that metals get rid of their outer electrons to become ions. And since it has 2 outer electrons, because it's in group 2, once it's got rid of those 2 electrons, it has a plus 2 charge. Fluorine, okay, group F, to become fluoride, not group F, sorry, group 7, that means it's got 7 electrons in its outer shell. It's a non-metal. It gains electrons to become an ion. It gains 1 electron so that it's got a full 8 electrons in its outer shell. But because it's gained 1 electron, that means that it has a negative charge. So my fluoride has this negative charge. Okay, then I write them in my table. So this is the first part of my method here. So I write their 2 charges below, plus 2, minus 1. And then I notice at the minute, these are not balanced. I do not have the same number of positive charges and negative charges. And what I need is I need more negative charges. So I'm going to need to add some more negative ions. So if I add another fluoride ion, what do I get in terms of my charges? So my left-hand side is plus 2, and now my right-hand side is minus 2. So that's it, I'm done. My charges are both balanced. So I have strontium fluoride, SrF, and then that 2 goes at the bottom there to tell me that I need 2 of those fluoride ions for this bond. Okay, let's have a look at the next example, the ionic formula for aluminium oxide. So let me find first my aluminium. So that is in group 3. It is a metal and it has 3 electrons in its outer shell. So because it's a metal, it loses those 3 electrons to become an ion and therefore has a positive 3 charge. And my oxide, that's from my oxygen, which is in group 6. And oxygen is a non-metal. It has 6 electrons in the outer shell, so it gains 2 electrons to fill its outer shell, and that gives it that charge of minus 2. Okay, now I do my table. So I've got my aluminium there, I've got my oxide there, and I notice at the minute I've got plus 3 and minus 2, so I need more negative charges. What happens if I add another oxide ion? Okay, now I've got plus 3 and I've got minus 4. Sorry, there is a minus sign there. You just can't quite see it. Minus 4 on my right-hand side because when I added that other oxide ion, I added another negative 2 charges. So it's still not balanced. That's okay. You keep going. So now I need more positive charges. So what happens if I add another aluminium? Okay, now I've got plus 6 and minus 4. I'm still not quite there. I need more negative charges. Eventually, you do get there. If I add one more oxide ion, I get plus 6, minus 6, that's balanced. So what did I have? I had 2 of the aluminium, Al2 at the bottom, and I had 3 of the oxide ion, so O3 at the bottom there. Okay, now let's look at a slightly different example. What is the formula for ammonium carbonate? So, ammonium and carbonate are actually both complex ions, so ions that are made from more than one element. And these are 2 of the ones that we had to learn, okay, that we had to learn the structures of. So we've got NH4 plus CO3 minus 2. Okay, so I'm going to put them in my table, and on my left hand side I have got a positive charge of +1, and on my right hand side I have got a negative charge of -2. So I need more positive ions. So let me add another ammonium, and that changes my left hand side to +2, and my right hand side is still -2. So that's all good. I can write NH4 brackets and then put that 2 outside of the brackets, and then carbonate CO3. Okay, now let's look at some dot and cross diagrams. So draw a dot and cross diagram for rubidium fluoride. Okay, so rubidium is group 1, and fluorine, which your fluoride ion comes from, is group 7. So my group 1 metal, remember, it loses that 1 outer electron, so it doesn't have any electrons in its outer shell. And your fluorine has 7 electrons originally in its outer shell, and it is going to gain 1 of those electrons so that the shell is full. Okay, now I'm going to put my charges on. So on my left hand side, my rubidium has a charge of +1 because it has lost an electron, and on my right hand side my fluoride has a charge of -1 because it has gained an electron. And so the charges are already balanced, so I am finished. That is perfect there. What happens if I need to draw a dot and cross diagram for gallium fluoride? Okay, gallium is group 3 and fluorine is group 7. So my gallium, I need it to have a complete outer shell by losing those 3 electrons in the outer shell. And my fluorine is going to need to gain 1 electron in its outer shell to have a full outer shell. So now let me put my charges on. So my gallium, I need +3 charge for my ion there. And for my fluoride, it has a -1 charge. Now let me look at my table, because at the minute I've got my gallium with a +3 charge and I've got my fluoride with a -1 charge. And those charges aren't balanced yet. So I need to balance those charges, and at the minute I need some more negative ions. How many more do I need? Well, if I add 2 more, then I get -3 on my right hand side and +3 on my left hand side, and that's when the charges are balanced. So I needed gallium, but then I needed 3 fluoride ions for that to balance. So gallium, F, and then 3 at the bottom there.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
A few little tips and tricks for this section. So first one is, remember that you can quickly work out the charge on an ion based on where it is in the periodic table. Okay, so firstly, is it a metal or is it a non-metal? If it's a metal, you look at the group number. That tells you how many electrons there are in its outer shell, and you get rid of that number of electrons, which leaves you with a positive charge equal to whatever that number of electrons was. So if you're in group 3, that leaves you with a +3 charge. Remember, if you're in a non-metal, then you are going to gain electrons, but you still use your group number. So let's say you were in group 6. you're a non-metal, you need to gain 2 electrons to have a full outer shell of 8. And since you gained those 2, then you're going to have a -2 charge. Next one is don't forget to use brackets if you have multiple complex ions, okay, but not if you only have one of a certain complex ion. So put the brackets around the whole formula for that complex ion, and then put your number 2, 3, however many of them you have at the bottom right hand side of that bracket. Make sure to include the square brackets with the charge and the number of ions in your dot and cross diagram. So square bracket, charge at the top right, and how many of them you actually need, okay, in the bottom right of your dot and cross diagrams.